Uh, so recursion is when you call itself. Okay. So here's a question. Find the nth Fibonacci number. Okay. So what's a Fibonacci number? So well, people have different conventions, but I'll go with A0 equals to 1 and A1 equals to 1. Let's say A is nothing, and I'll put A dot append 1 and A dot append 1. So A has 1 and 1, and now I want the next number to be the sum of the two previous ones. Okay, so I want to say A dot append A of 1 before plus A of 2 before. And if you look at what A is, it's now A is 1, 1, 2, right? And we can do another one, which now becomes, it's 1, 1, 2, 3, because you get 3 because 1 plus 2 is 3. Okay, let's see if you understood. What's the next number? If I do A dot append A negative 1 plus A negative 2, what's the next number? Negative 1 is going to pick up what? This number, right? A negative 2 is going to pick up 2, right? So what does that give you? 5, right? So it's going to give you 5, and now you have 1, 1, 2, 3, 5, right? Okay, what about another one? What's the next one? 8. Okay, so this is called the Fibonacci sequence. And let's say I want to make a function that would give you the nth Fibonacci sequence. Well, one way to do it will be to do exactly what we did. So we can define f of n, where f is the nth Fibonacci sequence. By the way, you can put a multi-line string right after the function, and that gives you a comment about the function. So this function calculates the nth Fibonacci sequence. Okay. And then let's say A is equal to 1, 1. That's the beginning, right? So while the length of A is less than n, what we do is like we keep increasing the list until the length of the list reaches n, and then we just show the last one, right? So if I do f of 1, then f of 1 is just 1, right? And in that case, because the length is 2, oh, I just realized I should really be doing this, okay. Less or equal to n. You just keep appending things in A, right? And then once it grows into big list so that it contains the nth term, now what you can do is return n, but n, it should be n minus 1, or just return the last number, okay? So that's what it is, and you can see Fibonacci of, let's see, this is a 0th one, so it's 1, 2, 3, 5. Fibonacci of 4 should be 5. Let's see if it correctly does it. Yeah, so it gives me Uh, while this is okay, uh, it grows the list, and it just grows the list, right? It gives you 89, and it might run into issues if you put a big number there. Okay. Uh, Now, there's another way to implement this by using recursion. So let me show you the recursion. df, I'll say fib for now. Oh, but I forgot this one. See, this thing, if you ask what question f is, then the doc string says this function calculates the nth Fibonacci sequence, which is exactly this thing that we had. Sometimes when you write a function, you also want to make a documentation about how to use the function or describe what it does. And this is the way you do it. You put triple quotes and you write about the function and you close the triple quotes. Because triple quotes are multi-line strings, you can put this in there. And when you ask what the function is, it correctly shows what it is. Okay. All right, so now let me show you how to do this by recursion. Okay? So define fib n. And we're just going to say that if n is 0, return 1. Okay? And elif n is 1, return 1 as well. Okay. Oh, no, I should really just do if n is 1 or less. So if n is 1 or less, then return 1. Okay. And then else, return. See, the equation is f of n is equals the sum of the two previous terms, right? That's what Fibonacci sequence does, right? aka Fibonacci. Right. So what I do is I say f of n minus 1 plus f of n. Okay? So this, oh, sorry, I made a mistake. I'm defining it as fib, so. Okay, so this looks kind of deceptive if you look at what we had to do before, right? We had to like make a function append new things by increasing the list, and then at some point you had to give back the last one. Over here, oh, another mistake, sorry. F of n is f of n minus 1 plus f of n minus 2. Just like here. I'm just repeating this definition, but I'm using fib, right? So this almost captures the definition itself. You also need a base case, but it does the same thing. If I do fib of 10, it gives you 89, which is exactly the same as this other guy, right? There's something called time it. Fib. executes this probably like 1,000 times or something. Okay, so this one takes 12.5 microseconds. What about the previous one? Oh, okay, that was actually, all right, so it seems like our recursion one is slower than the other guy. Yeah. Well, but then there is something called memoization, where uh, it remembers the value of the previous call. So what it does is, so known equals to something. Okay. And then we can make it to use something like no. So we're going to say known is just like how we started this. Known is 1, 1, okay? And then we're going to say if n is less or equals to the length of the known, known ones, then we will simply return the last value, return the knowns n minus 1 value. Is that how it is? There's some index problems. If n is strictly okay, so this is what you have to do, okay? And what you can say is k equals to the known value is this guy. Call it, and once you get the value, we're going to say known dot append k. I think that's what we do. Can return k. Oh, I have to. All right, so it's a bit cryptic, but I just want you to know this thing called memoization. So what it does is, if I do fib of 10, it gives me the same 89, but the interesting thing is the known now has every call that you've made before. So it memoized all the values that it called before. So next time you ask what fib of 10 is, it's going to give you the result right away because it knows that the 10th one is 89. So if I do the time it with this known thing, because we've already executed once, it gives you the answer much faster. Yeah, it's 119 nanoseconds, not microseconds. Nanosecond is like 1,000th, so there have been like 1,000, not 1,000, but 100 times faster execution time because we've memoized the previous versions. And even if you put something bigger, say 100, it's going to initially suffer because it has to build the list to a larger value. Oh, it's the same. Okay. F of 100, that's the value you get. Fib of 100, you get the same value, but this fib will be faster because it uses the memoized version. Okay, so that's the idea of recursive functions. I would say recursive functions, if it's not the memoized version, there's some functions out there that just memoizes the values automatically, so it's not as complicated as this. But if you use the memoized version, it's easier to understand what's going on than the non-memoized version. So that's sometimes used. Again, the things that I cover today are of the nature that you don't have to know it for you to program something, but it makes writing coding convenient. And because of that, a lot of other people will be using it. And because of that, when you're reading other people's code, you might see it. Okay? So that's the nature of the thing.